Here I am again, and I noticed that there's kind of a, I guess, well, I wouldn't say a pattern necessarily, but I guess once we got here, there was a stack memory module, so there's a sandbox here. I'm assuming that if we create a new program, yeah, I see here, there's stack memory nodes there, and then there's, it says console. So the signal multiplier is my next one, because we already did the signal reverser, or the sequence reverser. Okay, we have two stacks. What does it say? Read values from NA and NB. Boom, boom. Multiply the values and write the product to out. Okay, so we're just doing multiplication. But remember, our base operations are just addition. So to multiply, we basically have to add however many is from the other side. Now what I don't get is I don't think we need a stack memory to see. This is the thing, to reverse a sequence you need a stack memory, but to multiply I don't think you need that. I'm pretty sure multiplication is easier than that, because I mean, multiplication, you can just subtract one from a number and then add the other number for every time you subtract it. So that's what I don't get. You could just make a loop. Right? So like we'll have 1 and 8. Output's 8, right? Now I could make it more efficient and just pick the, the bigger number or whatever and swap them. So and that would make it go theoretically faster, but we don't even need to worry about that. Like, forget it. I could just take A, move up, down. We don't need the stack memory. Move up, down. Okay. Move up, ACC. And then we could just say subtract. If it's greater than 0, jump greater than 0. You just Let's do that. Okay, so basically what I'm doing here is I'm going to send a 1 over here. Okay. So I'm just gonna send a 1 over here for every number. In this number for each. I'm gonna break it down and just keep sending signals once. This one's gonna send this down. It's gonna move up to ACC, and then I'm just gonna add hold on. I could use the stack memory to make this easier, maybe, I suppose, because what's gonna have to happen is basically this is gonna have to listen. I'm gonna have to listen for when it can stop sending them, if you get what I mean. So but the problem is that it would have to know when to send it. Yeah, the stack memory doesn't help. It doesn't help with multiplying. So I guess I could save, and then I could get whatever this says. Boom. And then if it's a jump, if equals 0. Start. Okay, so if it sends a 1, so this is going to move left, up. And it's just going to say add up. The problem that I don't like about this is that, you know, this would be 1,000 times. These programs would be so much easier if you could jump to relative offset. What? They have that? But you can't jump based on... See, this would be so much easier if you could jump based on something else. If you could jump based on up or left or your backup number or something. But it's like, to jump you have to put it in this ACC, and that's so much less powerful, so much less efficient. It's like ridiculous. Like, you have to do all this extra computation to like clear it out, use it to try to jump, and then you have to like put something back in it again. So not only do I have to back up the number that I'm trying to add, I have to back up the sum. Right? Okay, so this thing's gonna loop. It's gonna take this left one, put it to ACC. Okay. If it's equal to 0, then we're gonna end. We're gonna swap, and we're gonna move ACC down. Okay, if it's not, then all that means it's a 1. So that means we have to take our backup, and you know what, we're gonna have to swap anyway. No, we won't have to swap, because we have to swap when we're done looking at... See, that's the thing about jumping. Okay, this is ridiculous. So we swap, and now we're gonna add up, and we're gonna loop. Okay, so start, move up, ACC, save it. Boom. Move down ACC, because it's going to move left. Okay, let's test this. Boom. Here's a 1, here's a 8. Save the 8. Bam. We're sending this 1 down. We subtract 1. Move 1 to the right. Bam. Move ACC up. Bam. This thing gets a 1. if it's not equal to 0, then we need to swap and then move ACC down. Boom, it's sending an 8 down. We add up, bam, there's an 8. Jump to loop, move left ACC. Something didn't work out right there. Hold on. This should have sent a 0. Hold on. This sent a 1. Boom, 1. Subtract 1. Move 1 to the right. Right? Jump start, move up ACC. That's not right. What? Hold on a second. I don't know what this start thing is supposed to do. Okay, we have a 1. We move 1 to the right. Move 0 to the right. Okay, now this thing isn't doing what it's supposed to do. Move left ACC. Move ACC up and then jump to the end. Swap, so 8 should be in the backup. 8's not in the backup, something's wrong. Yeah. Save. I think that's what I was missing. Bam, saved it. Okay, it added 14. After I move ACC down, I should move a 0 to ACC. I don't get why it's 14. Okay, there's a 4. And I'm multiplying 4 by 1, right? I save it. Jump loop. Hold on. This should be sending me... This should be sending me a 0. So it sends me a 1. It sends me a 4. Or 4 1s. 1, 2, 3, 4. So this should be sending me... This should keep on sending me a 1 until it's done. So it sends me an 8. Why is it taking it? Loop, move down, ACC, so it takes this one, bam. As long as it's a 1, so if it's equal to 0, then you start. As long as it's a 1, do I have a... Oh, I didn't jump to loop. Move ACC down. So jump, loop. Ooh, so I got 8, 4, 0, and then suddenly an 11 pops out. Interesting. It's supposed to be a 32. So an 8 should be in here, counting down. Eight times 4 is 32, so this one should only be sending 4s. Okay, here it starts over because it got a 0. Move up to ACC, save. It's a 4. Move down. ACC. So it's waiting on something. It receives a 1. Bam. Swaps. Move ACC down. Move down ACC. Receives a 1. Oh! When it swapped, it didn't save it again. There we go. There we go, okay. Needs to save it. Oh, yeah. Wow, that is so cool. I love that. I love when it finally works. It's just really cool. So cool. We have a... we don't use stacks, and we multiply numbers. See that? Bloop, 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 bloop. It multiplies them. So look, see, we're getting 32, 35, 4, 28, 35. That is awesome. It multiplied all those numbers. That is just great. Alright guys, that was fun. Segment 43786. Was that the one we did? Yeah, 43786. That is complete.